indeed. Recording in progress. No worries. Thanks, Aaron. So yeah, we'll go on and get started. And we'll run through this. If you guys please utilize our chat feature. It's in that right-hand corner if you're on a laptop, but make sure you select everyone in the drop-down menu so we can all see your questions. PTA members, as well as some members of the admin team will try to reply. And if we can't get an answer tonight, we will definitely take care of that and respond back later. So Aaron, thanks for queuing up the slides, and here we go.
Great. Just to reiterate what Nicole said, if you have any questions, use the chat feature. There's a little button down there underneath our stock happy business people. And then if you can, just mute yourself as we go here, just to minimize background noise for our speakers. And we are recording this session to post later.
All right. So yes, we will try and mute people. But if we miss, please make sure and mute yourselves. But yeah, next slide. All right, so a few updates. We'll run through these pretty quickly. Hopefully you guys know, we have a variety of subcommittees, a variety of BPA PTA subcommittees, BPA Dads, Run Fest, Dine Outs, Health and Wellness, and Fundraising. If you are interested in joining any of these committees, please reach out to our Vice President, Angie Bryant, at vicepresident@Burgess-Peterson.com. We are always looking for volunteers to participate in many of these committees. Health and Wellness actually spearheaded our guest speaker tonight. So we want everybody to be active. So please, if you're interested, just shoot her a note and we'll get you linked up with the right people. All right, so a couple of save the dates. We are going to have our garden cleanup day, Saturday, October 23rd from 9 a.m. to 12 p.m. Hopefully you guys know that we do have a garden at BPA. And as you can imagine, with limited folks in the building, it is in need of some tender love and care. So our garden coordinator, Ms. Rice, has organized a garden cleanup day. This is one of my family's favorite things to participate in. It's pretty, pretty physical. You go out there and you help clean up, pull some weeds, and just do what needs to be done to get our garden back in good shape. So we're asking that you come out, get your hands dirty while cleaning up for a good cause. You can help prep the garden for the next season. As you know, gardens are a lot of work, as well as socialize with some BPA buddies outside. So it's a good way to hopefully have some socially distanced fun with some buddies on a weekend. So if you're interested, please show up at 9 a.m. on the 23rd. Another save the date, we have Eva-ween, hosted by ICA. It will be Sunday, October 31st at 5 p.m. This is where everyone is invited to dress up or hand out candy. So if you're planning to hand out candy or any type of treats, or if you want to participate in the decorating and/or candy shoot contest, because we do want to remain safe and socially distant, please sign up at ICA.net. They got really creative last year, so I'm looking forward to seeing some of the cool stuff folks have this year. Also, for costume closet donations, they'll be accepted Thursday at the farmers market. So if you have some gently used costumes around the house, please consider donating those. And if you or someone in need needs a costume, please email education@ICA.net. That way we can make sure and swap resources. So again, this is our neighborhood partner, so we wanted to make sure we shared with all the folks here, since hopefully a lot of you guys will be participating. All right, our next save the date is our first dine out of the school year. It will be November 4th at Your Pie Grant Park. So for our new families, dine outs are an awesome way to meet some BPA families, and it's also a really awesome passive fundraising for our school. So this is where we coordinate with a local restaurant, and when you go to that restaurant and patronize on that given day, make sure you say BPA at checkout, and a percentage of your meal will then come back to the school. Again, it's very passive fundraising. You have to eat dinner, so we're hoping that you decide to patronize Your Pie that night, so BPA can get a percentage donated back. It's a chance to dine in with friends, or if you're not quite comfortable with that yet, totally get it. Choose takeout and take it home. If you say BPA at checkout, that money will still come back to the school. So we're really excited to have this partnership back up and running with one of our local restaurants. As you guys know, businesses have been hit hard the last year and a half. So we're just really excited to be able to have this on our plate. So shout out to our Dine Out committee who organized this. Hopefully this is just the first of many for the school year to come. Our next update is Pave the Way. Instead of selling chocolates, gift wrap, or magazines, we just ask for a donation given directly to the school, and it's through our Pave the Way program. This year, our goal is $12,500, and the two items that we are really raising initiatives for are shade structures for our courtyard play area, and new library books. Wow. So this is a live QR code. So please follow the link to our Burgess-Peterson Member Hub page on Burgess-Peterson Member Hub to make a donation. All donations will be tax deductible, so you'll get a receipt from our treasurer at tax time. Right now, I think we're at about $1,500 raised. So a long way to go for our goal, but we're super excited about our progress. Please share with your family members, your friends, your employers. We do know we have a couple companies that are matching employer donations, so we're coordinating to get checks from them. No donation is too small. We've even received allowance money in the mail from some of our students, which is super cute. I think we got $6 last week, so that is definitely added into that total. So no amounts too small, no amounts too big, but we're really looking forward to reaching our goal this year. As I mentioned, donations are open until the 17th. However, if you have a donation on the 18th, I'm sure we'll figure out a way to grab that. They're tax deductible. 100% of the money raised goes to BPA. We don't have to share that with anything. It's literally every dollar we raise goes to the school. So every dollar counts. And again, please make sure to share this with your friends and family members on social media, emails, texts, whatever you need. We even have some stock letters drafted if you need it. So if that's something that you are interested in, please feel free to let us know in the chat or one of our emails. And now I will kick it over to our Principal White, for a couple of updates.
Hey, thanks, Nicole. Thanks, everybody, for joining us tonight. We appreciate your attendance and your attention. I just had a few things I wanted to mention. I wanted to mention an update, or not really an update, but something that we are going to be sticking to a little bit more closely. Students who are arriving to school after the announcements have started, they get tardy passes, right? Most of you probably already know that, but after announcements have happened for the morning, kids are marked tardy. And if you are arriving after announcements are over, folks need to walk their kiddos into the front office. So you need to physically park your car, turn your car off, and walk your child into the office to help make sure they get a tardy pass and get off on their way to class. It's just become a little bit of a problem with kids squealing in 10, 15, 20 minutes after announcements, and then just wandering up to the front door unescorted. And that's really just not a safe scenario. So after our carpool crew leaves the front porch, you got to walk your kiddos into the office, please. Some of you may have also noticed that our process at school and in Atlanta Public Schools is to trigger, we send home a little letter that says, hey, just so you know, your kid has gotten 15 tardies or 5 unexcused absences or 10 unexcused absences. And when those thresholds of tardies or absences are met, it triggers some follow-up action. And one of those actions is to get a letter from the school social worker and myself that just says, hey, we noticed that these numbers have crept up a little bit and we want to bring your attention to it so we can make sure that unless your kiddo is sick, that they're at school as often as possible. And for the absences, if there are absences that are excused, then those don't count, technically count against you, right? We don't include those in our tally. So if your kiddo is sick, or if they're sent home for a COVID quarantine, or to be isolated because a kid in their class had COVID, those absences are excused, obviously. But it's the unexcused absences that that we tally and that can trigger our social worker or myself sending you a letter. So just wanted you to be aware that that is a thing that does happen, and not to be overly alarmed about it, but those letters are sent out to bring your attention to the fact that we do care about attendance and timely arrival, and we track those things, and we might be sending you a reminder. And if you do get one of those and you think it's an error, you can give us a call. We can check your information against this information in Infinite Campus, try to clear it up as best we can. Or if there are things that we can do to help you with that, we are happy to try to do that. Nicole already mentioned Garden Cleanup Day. Nicole, it cracked me up. The picture, one of the pictures that was on that slide showed our garden in what must have been like its first year, right? It was so pristine and there wasn't much growing and there was no chicken coop. And that was kind of cool to see. Our garden has been super productive this summer and this fall. But it's time now to rip some of that old stuff out and get ready for winter crops. So we really look forward to your help on Saturday. It'll be a nice time for some socializing, as Nicole mentioned. We have several projects. Miss Michelle, our garden guru, she has several projects lined up for us, and we're anxious to have some fun. And it'll be a good time. The weather looks like it's going to be fantastic. So I hope to see you there 9 o'clock on Saturday. Bring your garden gloves if you have some. The next thing I wanted to mention is coming up next week on Tuesday, so 1 week from tonight. I've been working with our literacy coach, Dr. Carla Miller, and our IB coach, Melanie Searcy, who's on the call. I see her face right above mine there. I wanted them to be able to bring forth and provide to families at BPA, especially families who are new to our school, but any family who wants to learn more about our phonics program or our International Baccalaureate primary years program. We'd love to give you some sort of 101 information about what a phonics lesson at BPA looks like, specifically in grades kindergarten, first, and second, where phonics, explicit phonics instruction is so important. So we wanted to give you a sense of what our teachers have been trained to do and what some of the buzz of a typical daily lesson in Orton Gillingham based phonics looks like. So you'll know what, when you see your kids tapping out sounds or doing some of the strategies they do in class, you'll know better about why they're doing that and maybe even support that work at home. And then as it pertains to our primary years program in the International Baccalaureate, we want you to have a better sense of what the learner profile is and what some of the planners or units of instruction that your kiddos might be engaged in this year. Wanted to give you a better sense of that structure and some of the background of our journey toward becoming an IB school. And that's going to happen here on Zoom next Tuesday at this same time. And the Zoom code is captured here on the screen if you want to jot that down. We will also push that out on Facebook. We'll send it out on Remind. So it will be readily available, but if it's handy, you could also jot that down or take a picture of the screen as well. And then next week, my final update is around, no, it's not true. I have 2 more. But the final one on the screen is around character dress up day next Friday. So next week is the last week in October, and historically the last week in October is Red Ribbon Week in many of our schools around the state and probably around the country, but certainly here in Atlanta Public. Red Ribbon Week is a week when we talk with our kids at the elementary, middle, and high school level about being drug-free, right? Saying no to drug use. And at the elementary school level, we try to keep that pretty light and pretty breezy and pretty fun. So we focus on what looks like spirit days. And so each day of the week, next week, we have a different theme or a different way that we hope your kiddos might dress up or bring something to school. As we talk about a little bit on the announcements, just a tiny touch about saying no to drugs. And I wanted to preview what that week will look like here. You're going to get this in your teachers' weekly newsletters. We'll post it on Facebook as well. But just this is your first taste of it because we just pushed this out today. On Monday of next week, we will ask students to wear something representing a team that they enjoy, right? It can be any kind of team at all that they like. So a jersey or some sort of t-shirt, or even if it's a color of a jersey or a team that they like, that'll be fine. So it's stay in the game, say no to drugs with your favorite team jersey. On Tuesday, we're going to invite students to, the theme is your future is drug-free. Dress up as what you want to be. So basically dress up as the profession you hope to have when you're a grown-up, as our kiddos. And that's been fun in the past. We've had students dress as ballet dancers, as doctors and lawyers and nurses and teachers, and it's a super cool thing. Then on Wednesday, we want to sock it to drugs, and we encourage our kiddos and staff to wear their craziest socks. On Thursday, we're too smart for drugs, so we encourage kids to dress up as nerdy as they can. Now, I'm not sure why smart and nerdy are the same, but on our Red Ribbon Week, they are. So it'll be Nerdy Day on Thursday. And then on Friday, we've already published that it's dress up, book character dress up day. And we invite kids to wear a costume that's portrays a character in a favorite book of theirs. It needs to be a character from some story, right? But just about every costume really is from some book. The only caveat there is I will remind is that I don't allow any toy weapons of any kind. So no toy guns, no toy swords, no toy lightsabers, no toy whatever you might accompany a costume that would be a representation of some weapon. We don't allow weapons or representations of weapons at school. And then the very final thing I wanted to say was just a shout out to our kids and our staff and to our parents for consenting for their students to get COVID testing at school. Hopefully you're on my Remind account, and I pushed out yesterday that we tested 414 students yesterday and 81 staff members yesterday. And it was the second day when we've had 0 presumed positive cases to report. And that felt really great because that is about 85, 86% of our students who are being screened every week. And that's a really great tipping point percentage. And it gives us a pretty good assurance on those testing days, especially when we had a total of 495 human beings tested yesterday and not a single presumed positive case. So that felt really great. Keep wearing those masks when you're out in public and not around just your family. Wash your hands and stay safe. And we're certainly trying to do that at school as well. I appreciate your attention, and thanks for letting me have the floor for just a few minutes, Nicole.
Of course, of course. And actually, before we move forward, Ms. Cersei did drop in the chat that Thursday, I believe it's this Thursday, will be BPA's Pink Out Day for breast cancer awareness as well. So just another little update for you guys if you would like to participate. Awesome. Next Thursday. Thank you for that correction. All right. So for our budget, I will just give a high level update. Our treasurer is on, but she is driving, so I'll do the best I can. Just some high level updates. Total holdings right now in our PTA account is $6,088.31. We are projecting to raise our Pave the Way budget of $12,500, and that money has been allocated for the remainder of the school year for incentives for students, as well as like our t-shirts, some art enrichment placeholders, as well as as well as some other strike transaction fees and supplies, as well as our big expenditures that we talked about earlier will be for our shade structures and library books. So no real change to any of that there. We are continuing to collect dollars from our swag orders as well as pay the way donations. So we are currently on target. Our next slide, Erin. All right, and then for our final update, BPA swag, now that the temperatures have cooled off, we've gotten quite a bit of interest in our new BPA hoodies. So the pre-order link is live. Again, that pre-order link is live. Please visit Burgess-Peterson Academy.memberhub.com to place your orders. You can do this for t-shirts as well as sweatshirts for youth and adult sizes. Please, please, please go and support. This is another sort of just low fundraising item for us. We love our new design. As you can tell, this is a map of our footprint there with a heart right over where BPA is. Super excited about that. It was designed by one of our BPA families. So we love it. And the sweatshirts are super great. It's right now, especially as the temperatures drop. I know we wear ours probably way more than we should, and we just got them. So please go and support. We're going to keep the link open through the 31st. We will try and order a few extras, but we don't want to tie up a lot of PTA money. So when I say few extras, I mean a few. So if you even think you're interested, they could make some great Christmas gifts or birthday gifts or what have you, please go and purchase. And that leads us into our guest speaker. And I mentioned our health and wellness team put this together. So I'm going to kick it over to our health and wellness chair to introduce our guest speaker.
Great. Thank you so much. Hey, everyone. I'm Beth Ament. I am on the Health and Wellness Committee. And I'm very excited to bring you the guest speaker tonight on behalf of the Health and Wellness Committee, Rebecca Tiller. She's going to be presenting on COVID-19 variants, vaccines, and more. But before I formally introduce her, I want to mention some of our programs for the rest of the year. So for November, what we have slated is a meditation and mindfulness session for our parents. The yoga session we did before was for the kids and the parents or guardians, but this next one for meditation is just going to be for the parents. And then we have a tips, no scripts for family wellness for parents in January. And February, we have simple, healthy habit session for home, work, and school. March, we have a nutrition class. And then April, we have art therapy for family and guardians. So just keep that in mind. Erin is an amazing communicator, and I'm sure she'll be pushing out information as we gather it about when those programs will be. So now on to our amazing speaker tonight. Rebecca Tiller is a microbiologist at the Centers for Disease Control and Prevention with expertise in zoonotic bacterial pathogens and infectious diseases. Since the COVID-19 pandemic began, Rebecca has been involved in CDC's COVID-19 response in various capacities, including leading efforts to establish a COVID-19 diagnostic surge lab at CDC for testing of clinical specimens for the detection and interrogation of SARS-CoV-2. Rebecca also served as a laboratory subject matter expert with the state, tribal, and local territories task force serving as CDC's liaison to the White House Testing and Diagnostics Working Group. Rebecca also deployed to CDC's occupational health clinics, supporting vaccine distribution efforts for CDC staff and contract employees. Rebecca and Barnum Tiller are proud parents of Carter Tiller. Can you stop, honey? Thank you. Sorry, Penelope's behind me. Are proud parents of Carter Tiller and Paula Tiller. Thanks, Rebecca. We're so grateful for you to be here. For everyone else, if you have any questions or anything, please feel free to use the chat, and I'm going to help facilitate those questions for her. Rebecca?
Okay, thank you, Beth. I tried to convince Beth not to say all of that.
It's important.
But thank you for the introduction. I appreciate it. Can you see my slides? I feel like my
Yes.
Yes. we
okay.
can.
Okay. So when I was asked to give this talk or just talk on COVID, I kind of waffled back and forth as to what to talk about, because there's really a lot going on with COVID, and I kind of deduced it down to 2 or 3 different topics. So I'm just going to do a high level overview of these 3 topics: variants, kids, and vaccines. And please tell me if my internet is getting compromised and if I'm freezing up, so that I can be aware if I'm having a gap in what I'm saying, because I'm getting notifications that my internet's not that great. Okay, so COVID-19 is caused by the virus SARS-CoV-2. Not everyone really knows the viral name, but and it is actually a single-stranded RNA virus. And I am going to get a little technical with in the first couple of slides here, just about viruses, because I think everyone really deserves to know how viruses interact with us in a pathogenic kind of way. So this particular virus is a single-stranded RNA virus. It's basically an encapsulated encapsulated nucleic acids, which are the genetic material that the viruses use to replicate themselves in a host cell. Viruses need to have a host cell to survive. They can't survive outside in the environment for very long. And so they carry the messages and the machinery to replicate inside of their nucleic acids, which is for this particular virus, it's this message RNA, which is what the M stands for in mRNA. So viruses replicate by entering into a host cell and producing all the proteins that help replicate the viral genome, and then new virons are generated inside of the cell, and then they break out of that host cell and they spread onto new cells. This is how it spreads throughout your body. And some scientists believe that viruses are not actually living organisms because they do not have cells of their own. They can't produce, they can't reproduce without a living a host cell, and they don't actively respond to changes in their environment. So how specifically does SARS-CoV-2 invade our cells? So we essentially have, as depicted on the previous slide, the outward poking things that come out of the cell, which are basically proteins. Those proteins have a very specific affinity. They really like these receptors that are on the outside of our host cells, which are the ACE2 cells here. So the SARS-CoV-2 spike protein basically links up with these receptors on our cells, and these 2 images in this slide basically are saying the same thing. They link up with those receptors on our cells, and our cells then just ingest the virus, and they enter into our cytoplasm, and then they just replicate. That's what they do. So once they replicate and then replicate and replicate, we start exhibiting symptoms. Our immune system starts to acknowledge that it's infected with this particular virus. It replicates in the body. We start coughing. We start having all kinds of symptoms. And we produce these respiratory droplets, which is how it's transmitted. We all know this. We've all been dealing with this long enough. But different droplets have different sizes. And so different droplets, smaller droplets can travel farther. Bigger droplets will, not travel as far. So this is why they have this varying 6-foot distance between people, because that's the farthest that, we can truly document a risk of someone coming into contact with someone else with SARS-CoV-2 for, droplet exposure. So you cough on somebody, you get it, and then everyone else around them gets it eventually over time. But viruses like SARS-CoV-2, they continuously change. Every time they enter into a human, they replicate and replicate and replicate. And every one of those replicating opportunities gives opportunity for genetic change, which brings us to where we are with variants. So we're really struggling or learning a lot about the mutation capacity and the ability for this particular virus to mutate as it has. So at the CDC, we have established a really huge national concerted effort across all of these public health laboratories in the United States, diagnostic laboratories, commercial laboratories, academic environments, universities. So we have on a weekly or bi-weekly basis, samples are coming into the labs at the CDC for processing, for surveillance, for sequencing. That's the only way that we can really determine genetic assessment and genetic sequences of the particular viruses that are circulating in the population, is to have samples sent to us. So it's a really big effort. And so far we have, between all of these commercial and academic and our public health laboratories, we have over 840,000 sequences available. And this is how we're able to really kind of see a snapshot of what's going on all over the country. So when we do genetic analysis of SARS-CoV-2, we have different categories of variants. And so we have variants of interest, variants of concern, and variants of high consequence. Variants of interest are when there is a specific genetic marker that has occurred that has been associated with certain things that could trigger larger public health action, like if there's changes to receptor binding or neutralization of antibodies, or any issues that that virus may have against therapeutics or treatments. So variants of interest, almost any variant can qualify as a variant of interest. So all the variants that are identified somehow fall in the spectrum of something of interest. Variants of concern are ones that actually do have evidence of increased transmissibility, decreased effectiveness of therapeutics, and decreased neutralization of antibodies that are produced from vaccination or through other antibody therapeutics like monoclonal antibody therapies. So we have actually identified quite a few variants of interest and variants of concern. Variants of high consequence are a pretty serious category. We luckily have not found or have identified a variant of high consequence. But this is one that the particular variant would defy any current testing algorithms that we have. We wouldn't be able to detect this particular variant, or it would overcome any immune responses elicited from vaccines, and it would evade any established treatments or therapeutics that we have. We have not found any variants of high consequence yet, luckily. So this is the variant list kind of continues growing, and these are just the main variants that we have been tracking over the past year and a half or so. The very first variant is the very first SARS-CoV-2 that came out of Wuhan, and that is Alpha. So that's the first one. In the very beginning of variant surveillance, we had all these weird names like B117, B118, P3, B1621. I mean, it was very difficult as a global community for us to keep up with all of these different variants. So WHO established another nomenclature, alpha, delta, gamma, epsilon, which has made it a lot easier for us to kind of communicate and articulate variants as they're circulating, because they are eventually circulating globally. So these are all the variants. Right now, we really have in the front of our minds the Delta variant. So SARS-CoV is constantly changing this virus, and it's accumulating mutations every time it mutates. And it's expected. I mean, that's what viruses do. It's not, it's not as similar to the flu. It is a different virus than the flu. But some variants will emerge and they'll disappear. It's just a matter of their fitness. So right now we have the Delta variant, which is the most dominant variant here in the United States right now. And it is more contagious. It can cause more severe illness simply because more virons exit some person than the alpha variant, which was the very first strain that, and the comparative strain that we have, the very first strain that came out of Wuhan. The Delta variant produces a lot more virons in your body, so you're spewing out basically more virus. So it's more of it's a dose exposure thing as well to anyone that's around you. Unvaccinated people are of the greatest concern with the Delta variant and with any variant, and always have been. Before we had the vaccine, it was always, we were all in the same boat. And now we have this, when it comes to public health, we're looking at vaccinated folks and unvaccinated folks in the context of variants and therapeutics and things like that. And unvaccinated people are at the highest risk in general. So a lot of the public health mitigation strategies that we have are for our unmedicated or our unvaccinated population, which a majority of them, and I'll get to this in the talk in a minute, are our children. So vaccinated people, you can acquire Delta variant, and you can replicate it, and you can transmit it, but you don't transmit it at the same levels as an unvaccinated individual. So there's this, so just to give some context of where SARS-CoV-2 and COVID falls in the spectrum of other infectious viruses. There's this concept of the reproduction number. It's called the R0, and it's basically how many people can one person infected with that virus infect. So with measles, for instance, it is next to smallpox. It's the most infectious virus out there. So one person can infect 9 people if they're in contact with any of those people. If they're in a room with 15 people, 9 of them are going to get infected. Chickenpox, one person can infect 8.5 people. So, you kind of move on down, and COVID-19, the alpha strain of COVID-19, the R0 for the alpha strain was about 2.5, 3 people. So the R0 for Delta has doubled. It's somewhere between 5 and 8 people. So we're seeing that this particular variant of SARS can infect twice as many people as the original strain that emerged out of Wuhan almost 2 years ago now. This is just a data graph from the CDC data tracker, and I have a list of data resources at the end of this slide deck if people are interested in knowing where to just get national level surveillance. But it's basically showing that the Delta variant is the most dominant variant here. It's showing from the left to the right the variant compositions from all of the sequencing that's been conducted. And since July to now, pretty much the Delta variant has taken over the primary variant circulating in the United States right now. So what does this mean for kids? We've got, vaccinated adults, unvaccinated children. It affects the way that we, go about in our daily lives. And of course, we all want them to go back to school, and we want everyone to have normal lives. And we have seen, we've always seen that children are less affected by COVID, and it's still generally true. Fewer cases have been reported of COVID in children ages 0 to 17 compared to adults, those 18 and older. Children can get sick, and they can spread it, but they don't get as acutely ill. But as this fall has started, and with the emergence of the Delta variant, we have seen an increasing uptick of cases of children between the ages of 0 and 15. So if you track the yellow lines, you'll see that they have inversely increased since the onset of Delta and since we've started school back in person. So most of these kids are just testing positive. They're not really acutely ill, but they are carrying it, and they, can transmit it. And some children can develop severe illness. Many of them do not. Lots of children with underlying medical conditions are at increased risk. for other types of complications with COVID. But generally, most children are not really as affected as adults. And so this is a big question, like, why don't kids get as sick as adults? And there's a lot of research in this little area, but there were some preliminary theories as to why this may happen. One is that other kids kids are constantly exposed to other coronaviruses, the common cold and things like that. And that those massive exposures, when they're at this young age and to each other with all these different colds, is potentially conferring some protection for them against this particular coronavirus. Also, kids are much less likely to have underlying health conditions like we do in the older ages, diabetes and heart disease and things like that. And most interestingly, I think is that children have reduced expression of the ACE2 receptor, which is what I showed you in one of the very first slides, which is basically the lock and key for the virus to enter your cells and start replicating. So if children don't have these receptors on their cells, they can't, the viruses can't enter their cells and start producing. And then generally, just because of the immunobiology of children, they produce lower levels of inflammatory response, cytokines, which limits the massive inflammatory sequelae that we see with adults. So, but some children do actually develop some pretty severe illness, and it's very rare, and I'm going to talk about it briefly. And it's called MIS-C. So MIS-C is called multi-inflammatory syndrome in children. There's also MIS-A, which is in adults. And these are two different syndromes that when we first started tracking COVID and trying to really understand the long-term effects of COVID and all of our age demographics, this was one that really kind of stood out. It was occurring frequently enough that it required a case definition, and it required us to, have the clinical community really understand that this is something that, should be identified and captured from a surveillance perspective. So MIS-C is a condition where different body parts can just become really inflamed, and often all at the same time. So heart, lungs, kidneys. And children often present a few weeks after they have been exposed or tested positive with many different symptoms all at the same time. So there's our pediatric community are very aware of this particular very rare occurrence, and it is being tracked. So far in the US, we've had within all of the COVID cases that we've had in the pediatric age range, we've had about 5,000 patients meeting the case definition and about 46 presumed fatalities from MIS-C. The median age was about 9 years old. 61% were Hispanic Latino or Black non-Hispanic. 98% had a positive test result for SARS, and then 60% were boys. Another condition that can emerge from kids and COVID and also in adults is called long COVID. And this is in response to a pre-question that we got via Erin from the secretary. So long COVID, there's really, this is essentially, there's not a really good case definition for long COVID, but long COVID is any individual, adult or child, that is exhibiting persistent symptoms of COVID beyond 28 days. And if you think about when you get like the flu or something, you normally resolve and are kind of feeling better after a couple weeks. After a month, it's kind of like, okay, what's going on? And then sometimes long COVID is way more than that. I mean, it's 5 weeks, six weeks, a couple of months. I mean, and there are individuals who it is going on for a very long period of time. And so there have been some studies that have been triggered to look at this in children, because we don't see acute illness in children, but we do see these delayed long COVID presentations that can appear. and they're very rare. There's a study that I pulled this information from the UK, where they followed a couple of 100,000 children over a period of time. Many of them never tested positive for COVID, but those that did, they followed them. They did find that in the acute phase, if they did have an acute phase, they had about 6 of the symptoms listed to the right, and 2 of the persisting symptoms went on after 28 days. And the most common recorded symptoms were headache, fatigue, and then sore throat. And it really is broken down within age groups. So this is still being looked at and trying to be better understood. But it is something that we are trying to better comprehend in the pediatric age group. So how do we protect our kids? I mean, we want to try to get, them protected in some way, and vaccines right now are one of the best ways that we can do that. And protecting our children and preventing new variants of the COVID-19 virus can be accomplished through vaccination. So right now we have 3 approved vaccines in the United States. The Pfizer-BioNTech and the Moderna, which are both mRNA vaccines, and then the Johnson & Johnson, which is it's a double-stranded vaccine, a double-stranded DNA vaccine, which is why it can be handled or stored in a different holding temperature than the other 2 vaccines. So we have both of these vaccines have been approved for different age groups. They've gone through all their different clinical trials. And we have, our children 12 and up are approved for the only available vaccine we have for children below the age of 16 is Pfizer. So Pfizer did actually just submit all of their FDA data from their phase 1, 2, and 3 trials for evaluation for the ages of 5 to 11. So this phase trial, so when you do vaccine evaluation in children, as you all can imagine, it's complicated, and it takes a lot to figure out the right dosage. So those of us who got the Pfizer adult dose of 12 and up, that was decided it was a 30 microgram dose of the vaccine. So the first thing when you're trying to evaluate that vaccine that has shown effectiveness in an older age group, the first thing you're going to do in the younger evaluation group is assess dosage. So in phase 1, they assessed a 10 microgram, a 20 microgram, and a 30 microgram dosage in a smaller phase 1 evaluation group. And out of that group, they determined that the 10 microgram dose was probably the best dose to move forward with in the next 2 phases of the trial, which they did. So the phase 2 trial, which was the 10 microgram dose, included 2,268 participants aged 5 to 12 years old from 4 different countries and 90 different clinical trial sites. So the 10 microgram dose was administered to all of those participants, or a portion of them, because there's also a control group that gets a placebo. And it demonstrated near exact efficacy in this age group as it did in the people 16 to 25 years old that were immunized with the 30 microgram dose. I unfortunately don't have access or visibility on the actual hard data because it's trapped still with FDA, but they are looking at it and reviewing it. But overall, it looks very promising, and we're hoping to have it reviewed and approved by the end of this month, if not by the first week of November or so. So we would have a vaccine available for 5 to 11-year-olds from Pfizer, and it would be the mRNA vaccine. So I did just want to kind of go through how the mRNA vaccines work, and because I think it's a mystery to a lot of people. People have come and said, is it a protein? Is it a this or that? It is kind of all of those things, because it's really a very ingenious approach to utilizing your own, it's a very natural approach to utilizing your own cellular machinery to stimulate your immune system. So basically, when you get a shot in your arm, it's introducing Normal vaccines like the flu is introducing kind of a piece of the virus, like a protein of the virus or bacteria or whatever. And it shows it to your immune system, and your immune system develops antibodies, which are these Y-shaped things on the right. But what the mRNA vaccine does is it goes into your cells in your arm, and the cells in your arm, it enters into your cells just like the virus does, because it's covered in a lipid nanoparticle coating. It enters into your cells. The mRNA is transcribed, and it's basically the dictionary for your body to make the spike protein, which comes out and it's presented on the outside of your cell. So the cell breaks after it makes the protein. Your cells inside, and this is all occurring in the cytoplasm of your cell, it breaks the mRNA down into small pieces and it disappears. So those who think that this mRNA vaccine is roaming around in your body for 10 years with a microchip is not correct. It breaks down, it's very fragile, and it doesn't last but for a few days, if that. Once the spike protein is produced, your body sees it. It produces the antibodies, which are these Y-shaped things on the right. So, and it remembers when it sees a real SARS-CoV-2 virus, it will come and surround that virus entirely with those antibodies. And those are called neutralizing antibodies, which means they will kill that virus. And that's what you want. So your body will continue to produce the spike protein for a while. You'll produce antibodies, and those antibodies is kind of what we're right now trying to assess how long they survive in your body after you're vaccinated. But most of the proteins will roam around in your body like any other proteins that you make for a few weeks. And then your body's immune system quickly identifies them and it gets them out of your body. That's kind of what your body does. So it's learned the enemy, everything gets flushed out of your system, but your immune response persists. So some just like clarification on this vaccine. So can the COVID vaccine change your DNA? No, it cannot. This is kind of a big question that we get. This virus enters into your cell surface, and all of the activity, as with the real virus, occurs out in the cytoplasm. Our DNA is stored inside of our nucleus, so it's totally separated from where this mRNA activity is occurring. And the cells break down and get rid of the RNA after it's used it for instructions to make the spike protein. So I hope that was clear. So once we are vaccinated, we can start to see the eventual protection of each other in our community. And this is really where we want to be. We want to be yellow. We want to have an immunized and healthy population, preferably through, a vaccine and not through a previous or, a traumatic type of infection. But this is really where we want to be, is to have an immunized and healthy population. And this is what we're talking about when we talk about herd immunity. Our immunized status can protect people around us, and including our children, which is where we are. So right now, I think we're at about 69% of vaccinates in our community right now, of people who've had, of all ages, at least one shot of one of the available vaccines. So these are it's a small list of resources, but this is, and I have more, but this is some if you all want to, take a look at those. The COVID data tracker is where I got a lot of the data. If you want to see a global picture, WHO is a great resource for pediatrics. The AAP is a great place to go if you have any questions about pediatrics and COVID and anything for that matter. Okay, and that's it. Thank you for your patience, and I will take any questions if you have any.
So there's a couple of questions in the chat, and I apologize if you have already answered these. I was a little distracted during part of this, but luckily I heard it before. Erin and I got a preview of it. Great job, and thank you so much for being here. We've got a question from David White. What's a PANGO? P-A-N-G.
David, I knew somebody was going to ask me that. And it's an acronym
Yeah, it's on the
It-
variant slide.
Yeah. It's
Pangolin.
it is the Pango lineage, I know. It's the phylogenetic assignment of named global outbreak lineages.
Stay in
I
school.
wondered, it's because all of these lineages, they are associated with some kind of geographic origin. I mean, they came out of some country first. So their Pango lineage is kind of where they phylogenetically emerged in the world. It's their global outbreak lineage. I thought it was a program that they use to assign the lineage, like a bioinformatics program, but that's what Pango is, phylogenetic assignment of named global outbreak lineages.
Thank you.
It kind of sounds like an animated character.
Yeah, Pango.
Yeah. So Aaron had a question. When the vaccine is available for kiddos, will they likely have some of the side effects that adults have, like aches, light fever, etc.? Also, can you talk a little bit about long COVID in kids?
Yeah, so I can't say about the side effects of COVID in children, simply because their presentation is so very different in natural infection. So I can't answer that. I mean, we'd really need to look at the FDA data and see what they saw during the clinical trials, the phase 3 trial. My suspicion is yes, there will probably be some kind of, just immediate reaction, just because you're generating the spike protein. So with children, the actual virus can't really invade their cells as readily, or the binding affinity in children is not as high. So you don't get as many, viruses entering cells and then your cells producing the spike protein. When you're vaccinated, it's just an automated process. So, and which is why I think they chose the 10 microgram dose, which is a lower dose than what we adults get. So that was it was a balance between getting the appropriate immune response that wasn't causing side effects that would prevent, you from wanting to get vaccinated. So I think it's going to be similar to probably what we saw. I know and anybody I know who's gotten vaccinated, we all have various, reactions to the vaccine, but they were short-lived, and, essentially we were like, well, we know it's working. So I will say that if I can get some visibility on the data, I can try to distill it down, and I'd be happy to, email me and I can, present it or show it to you in some way that's easy to digest, because these FDA packets are huge.
Great.
And then long COVID, yeah.
Did you want to talk about long COVID, or are you still there? Uh-oh.
Sure, on this, and it was really difficult to get a hard, concrete answer. One of the answers that I did see in a study was that in about 4.5 or 5% of kids who are exposed to COVID, about 4.5 or 5% will potentially have long COVID. So they'll just kind of have persistent symptoms like brain fog and anxiety and headaches, and remnant symptoms of what they may have exhibited in their acute stage of their infection. But it's very difficult to parse out. So I mean, if any of you all are have had kids that have had COVID or experienced it, and you're suspecting that they are having these long-lasting sequelae, I would talk to your pediatrician and see how they can work with you on better understanding what's going on. There's a lot going on with our kids right now, especially coming back into school from being out. And I mean, any of y'all educators and parents are aware of all of that. So it's difficult to tease out.
Great, thank you. If the reproduction number is higher, why hasn't there been updated contact tracing information?
I don't know exactly how to answer that question. I mean, contact tracing is, and I mean, it depends on what system in which contact tracing is occurring. I mean, we have it occurring in different environments. I know it's happening, you know, at work where I am, and in the school systems. In our schools, we're wearing masks, and we have distancing, and we have cohorting, you know, groups, you know, classes and kids not mixing, and for the most part. And I'm speaking on behalf of, I've also got one in a middle school, you know, King. So, so it's up to those environments to determine, you know, how to best assess what kids around a positive child was at risk. And that's really kind of up to, you know, Atlanta Public Schools, and maybe David can respond to this, but I heard that they just hired like 30 epidemiologists or something like that. Atlanta Public Schools.
I heard that too. I have not
Yeah.
yet seen any of them.
Yeah. So, you know, moving forward, that may, you know, help bring some clarity and harmonization as to how different schools in the systems are doing different things. But yeah, I mean, I can look into that, how contact tracing has been affected by having a you know, a higher reproductive number with the virus, but it's the same rules. You know, anyone who's within 6 feet and had 15 minutes or more of close contact with someone without a mask is considered high risk. So,
Okay.
yeah.
And at Burgess-Peterson, because we are always masked inside the building, we reduce that to 3 feet. So if kids are around each other, even within 3 feet and masked, we still consider that a close contact if a neighbor has a presumed positive case.
Yeah, I don't think that all the schools are doing it like that. And I think that there was data that came out that did demonstrate even unmasked children that a 3 feet distance, because children don't have the same symptoms or transmissibility as adults do, that 3 feet is a suitable distance for risk to assess risk and exposure.
Yeah, there's a good bit of variability, I think, Rebecca.
Mm-hmm.
Yeah.
Okay, so I am very focused on respecting everyone's time. I think we have time for one more quick question, and then I'm going to turn it over to Nicole. So here is the last question for all of the questions that are unanswered. I'll happily gather these together, and if Rebecca has time, she's already dedicated a lot of time tonight, but if she has time, we can try to get those answered for you. But here's the last question. Did I hear you say that it is expected to be EUA by the end of this month?
Yes. Well, beginning of November, end of October. That's what we're hoping. Yep.
Perfect. That was a quick one.
For 5 to 11. They did actually have in their phase 3, they did have 0 to 4-year-olds, but they did not submit that data to the FDA. So they only did 5 to 11.
Okay, great.
Mm-hmm.
Thank you again, Rebecca. We really appreciate your time.
You're welcome. Thank you.
Impressive knowledge. This was fantastic.
All right.
All right.
Awesome. Rebecca, just from as well, the PTA as well, thank you so much for your time and putting together this presentation and walking us through it. Lots of valuable information, and it clarified a few things for me personally. So thank you so much. You hear things on the news, but it's different coming from a BPA parent. So we truly appreciate you taking the time for us tonight. I see, okay, I was looking at comments. I see lots of "Let's Go Braves." I know the game is on. You can see the Dodger banner in the back, so I won't hold it against you, David. But in order to respect everyone's time, thank you so much for joining our PTA meeting tonight. And before we get out of here, I would be remiss if I didn't say congratulations to our principal, David White, for being nominated as AP Principal of the Year. We are super excited. That video was very cute that was posted online. If you aren't a member of our BPA parent Facebook group, please join. There's a very cute video of David being surprised by our superintendent, as well as a class in the media center. Principal of the Year, being nominated is an awesome, awesome, awesome recognition. And if we have any say, just let us know and we'll spam the voting app if there is one, because we don't think there's anybody
I
greater.
don't know how to bring it home. I'm not sure how to win. I'm thrilled to be a finalist. Thank you, Nicole.
Awesome. So no, we just wanted to say thank you. And we know whatever needs to be done, you'll get it done. It is 7:05. We are 5 minutes over. So sorry, everyone. If there are any questions, feel free to reach out to PTA, but have a great night. Talk to you all later.